Imagine, just for a moment, a perfectly quiet room, a blank screen, and the faint, rhythmic pulse of a digital machine, just waiting. Today, we're taking a journey into the very heart of how computers actually work. We're going to strip away all the noise, the hype, the complex jargon, and we are going to start from the absolute ground up.
So, I want you to meet Asha. And honestly, she represents the curious beginner in every single one of us. Asha is sitting in front of her laptop, and she's got this puzzled look on her face. The screen is entirely blank except for that one solitary blinking line. She stares at it. Nothing moves, nothing speaks, yet somehow people claim that this silent, completely lifeless machine powers artificial intelligence, launches rockets into space, and connects the entire internet. I mean, how could that possibly be?
She turns toward her mentor. Let's call him Professor Byte. And she voices this quiet mix of fear and wonder that anyone who has ever felt intimidated by technology has experienced. She asks him a beautifully simple, profound question. She says, "How can something so silent change the world? When I look at this screen, I don't see intelligence. I literally only see a blinking line." Professor Byte just gives her this wise, calming smile. You see, he doesn't hand her a heavy textbook filled with complex formulas. He doesn't start rambling about neural networks or massive algorithms. Instead, he just points at the screen and says, "That blinking line is an invitation, because behind that silence lies something extraordinary." He is preparing to show her the hidden mechanics of computation, not as some impossible mathematical mystery, but as a clean, structured system of logic.
Asha thinks about this for a second. She really wants to understand the first principles, what is actually happening beneath the glass and metal. So she asks the question that shifts this whole thing from mystery to structure. She asks, "Professor Byte, when I type a command and press enter, who is actually listening?" And you know, it's the absolute perfect question, because computers on their own, they don't just listen.
Professor Byte smiles again. "Ah," he says, "you've just discovered the invisible worker." He introduces her to something called the Python interpreter. Now, don't think of the interpreter as just a piece of software. Think of it as a literal invisible worker standing squarely between you, the human, and the machine. It's a translator. It completely bridges the gap between what you want to happen and what the hardware can actually physically do. To really get this, look at these two entirely different worlds. Over on one side, you have human language. That's our ideas, our words, our logic, concepts like, hey, print this out, or calculate that number. But on the other side, you have machine language, electrical signals, zeros, ones, microscopic switches turning on and off millions of times a second. There's a massive, seemingly uncrossable gap here. And right in the middle of those two worlds stands our translator. Professor Byte explains this so beautifully. He says computers don't even understand English, or French, or Hindi. They only understand electrical instructions. Python exists because humans need a friendlier language. See, Python is not actually the language of the computer itself. No way. It is a bridge. It's designed to be read by you so that the invisible worker can then translate your thoughts into the raw electrical signals the machine actually obeys.
Now, this brings in a friend of theirs, Ravi. Ravi is a practical builder. He loves to experiment. He's been listening in, and he suddenly grasps the true philosophy of what coding actually is. He sums it up perfectly. He says, wait, so Python is less about teaching computers and more about helping humans think clearly? Professor Byte nods. Exactly. And guys, this is a massive shift in perspective. Programming isn't about memorizing weird machine codes. It's simply a tool for structuring your own human thoughts.
So, all those intimidating technical terms you hear, they are literally just fancy words for ordinary, everyday things. Let's anchor this in reality. Variables, they are just cardboard boxes with a Sharpie label where you store stuff. Functions, think of them like kitchen appliances. You put raw ingredients in, and a specific result comes out. Loops, that's just a washing machine repeating its cycles over and over. And algorithms, they are simply recipes, step-by-step instructions. There's absolutely nothing magical about it.
Ravi, totally eager to test this out, says, "Okay, enough talking. Let's actually see it." He wants to break down the exact sequence of what happens when a command is given. It goes like this. Step 1. You write a clear human instruction. Step 2. The Python interpreter, our invisible worker, translates that instruction. Step 3. The machine obeys. It's a literal sequence, a chain of events that turns a mere thought into a physical action.
So, Ravi turns to the keyboard and types the classic first line of code that pretty much every programmer in history starts with. He types the word print, followed by some parentheses and quotation marks holding the words "Hello World." He hits enter, and boom, instantly the screen replies with the text. The invisible worker did its job flawlessly.
Asha smiles as she watches the text appear. It listened, she whispers. But Professor Byte gently corrects her. No, he says, it obeyed. This is a crucial distinction. Computers do not possess wisdom. They don't assume what you meant to say. What they possess is absolute, literal obedience. You give a precise command, they execute it precisely.
But what happens when we aren't precise? Asha decides to try it out. She types the exact same command, but this time she forgets the quotation marks. She hits enter, and instantly the screen flashes a bright red message. Syntax error. Asha completely panics. Her heart races. "I broke Python," she gasps, staring at the error message like she just initiated a meltdown. Ravi just laughs this great, good-natured laugh. "Congratulations," he says. "You've officially become a programmer." Making mistakes is not a sign of failure in coding, folks. It is the daily reality. Every single programmer on Earth, no matter how advanced they are, sees errors every single day. It's just a normal part of communicating with that invisible worker.
Professor Byte steps in and completely reframes the whole concept of making a mistake. Errors aren't enemies, he explains. They're teachers. They are simply messages from the interpreter. I want you to think of it like a GPS recalculating your route. The computer isn't judging you for taking a wrong turn. The invisible worker is just politely tapping you on the shoulder, saying, "Hey, I didn't quite understand that translation. Could you clarify?"
And once you realize that you literally cannot break the machine, this incredible moment of wonder starts to set in. Because look at how this scales. You start with a simple command, like printing a single word. Then maybe you tell the machine to repeat that command in a loop. Eventually, by layering enough of these very simple, precise instructions, you reach the astonishing complexity of modern artificial intelligence. But it all starts with the exact same foundational logic.
Let's just pause and let this philosophical takeaway from Professor Byte really sink in. He looks at Asha and says, "Do you know something beautiful, Asha? The internet, artificial intelligence, even space missions, all of them began with simple instructions. Great systems are merely small ideas repeated carefully. Modern AI is not magic, it is just structured mathematics and simple instructions layered carefully on top of one another." And really, this brings us to the mental architecture of intelligence itself. Learning this stuff isn't about frantic memorization. It's a structured, ordered path. You don't need to be a genius to outrun the field. You just need to take the next clear step. We build one layer at a time. The complex models, the agents, the AI, they all rely on this exact same foundational architecture. You are literally building the mind before the machine.
So, if we take a step back and distill everything we've uncovered in this explainer today, the ultimate lesson is this. Programming is not typing. Programming is not memorizing syntax. Programming is simply learning how to think clearly. Every single program out there, from a basic calculator to a massive AI agent, is just a sequence of human thoughts translated into instructions for a machine.
Asha closes her laptop. She looks at the blinking cursor one last time before putting the computer to sleep. Just yesterday, that quiet room and that blank screen felt totally mysterious and intimidating. But today it feels familiar. She realizes the machine wasn't ever judging her. It was just waiting for her to speak clearly. She has completely transformed from confused to empowered. But right as the screen goes dark, another question pops into her mind. She turns back to her mentor with this new, brilliant, provocative thought. "Professor Byte," she asks, "if Python can display messages, and if it can follow instructions, can it also remember things? Like, can it hold on to information for later?" Professor Byte smiles, and there is this glimmer of real excitement in his eyes. "Ah," he says softly, "now we are ready to teach Python memory." And that changes absolutely everything. And you know what? That is exactly where we will pick up next time as we continue to build our understanding, layer by careful layer. Keep questioning, keep experimenting, and always remember to think clearly.